Today we're diving into the technical details of a feature in our Fleet product of how we get telemetry from devices in near to real time. So some background. Fleet is an open source platform for managing and gathering telemetry from devices such as laptops, desktops, VM, etc. It uses agents, OS query agents. Both Fleet and OS query are open source projects. And those agents run on these devices like laptops, and they report back to the Fleet server. So one of Fleet's features is live querying, which is the ability to query information from devices in near real time. So I will first demonstrate how this would look. So from a user interface, I go to my dashboard, go to queries. I said, hey, add query, and I type in a query. I'm going to use this simple query. I'm going to get name and version from OS version. I pick this one because it runs on all OSs. I click live query, then I select my targets, which is OSs or teams. I'm going to select all hosts. I'm going to click run, and then it's running, and the hosts are reporting results back. And we see different names, different OS versions here listed. And once all the hosts that are online have reported, the query ends. So just for terminology, hosts and devices are kind of interchangeable. So in Fleet, we call them hosts. So let's do this on the command line. So I can do the same thing on the command line using our command line tool, Fleet Control. I do a query and I do labels. So basically I'm running the same thing, but using the command line tool. So just so you can see it. And I'm running a development version here. So the host results are coming back. So basically the same results, but in JSON format. And I see that all the hosts that are online have reported, but command line tool will keep running. So if any hosts come online, it'll continue reporting. So I'm going to kill it for now. So let's go back and let's kind of discuss how things work. So here I have a simple diagram. And so we have in production, we would run multiple Fleet servers. And there will be a load balancer here, which is not shown in this diagram. Okay, so initially we went to the web UI and we told the Fleet server to run a live query. We put in all the information, the details, and what this server does first is it writes that information into the database. So then this information, this query campaign is visible to all the servers. Then these hosts / devices, they check in with the servers about once every 5-10 seconds, depending on the config. So they will check in with the server, and the server will tell them, oh, there's a query that you need to be running. So they get this query and they run it. Then they run the query and they get the results back to the server. And since there's multiple servers, right, what happens is each server will push the results into the Redis cache using a pub/sub feature of the Redis. So all the servers are pushing their results into the Redis cache. But only one server is communicating with the client. And so this server is going to subscribe and is going to be getting those results. It's going to be getting those results and pushing them back out to the client. So in the UI that we saw here, the results, as you can see, the results were kind of coming in near to real time. That is because this is using WebSockets. We also have a REST API implementation that doesn't use WebSockets, which is documented in the public documentation. And that will just, once all the results come in, it'll push them all back out as a result. So we have the REST-based API that will use this method, and then we also have kind of the WebSockets API, which is used by our user interface, the web UI, and our Fleet Control command line tool. Thanks for watching.